Everything clear? Is everything clear?
Yeah, logic.
Okay. We start review vector, and for online students, this is required, and you are going to listen to it. For you guys, obviously, vector is some advanced number. Normally, we have a number like 7 or 5. This 5, we just know is the number 5. Doesn't give us direction. Doesn't give us direction. In real world, many times, besides we want to know the value, how big or how small it is, we also want to know the direction. Without vector, we can do a little bit of direction, like +5, maybe is that direction, -5 is that direction. Or we can say +5 is upward, -5 is downward. But we want the direction is everywhere, so we need a vector. We need a vector. All right? And you can treat it as an advanced number. Advanced number. For example, let's say 3, 2, 3, 4. Okay. This is a vector. For handwriting, people normally write vertically. But like I said, in print, in Microsoft Word, it's hard to write like that. So people, for same thing, we want to do horizontally. So this means next line. Okay? This means this. In the final exam, when you see this, you should know that. In many textbooks, for the convenience of printing, they use this format. So, 3, 4. In our class, I always use these very nicely vertical. So 1, 2. Where is this one, guys? To draw it.
Right side.
I want to visual it. So 1, 2, 3.
Yeah.
And 4. Okay. So this is a 1, 2, 3. And this is a 1, 2, 3, 4. Let me one. Okay, so that's about here. Okay, so this is this vector. This is this. 3 and 4. Okay, let me write it. 3 and 4. This is a vector. The length is how big it is. Okay, and it has a direction. It has a direction. Okay, what's the length of this vector? Let me name it the vector, okay? Normally, we use a symbol, there's an arrow. This means a vector. What's the length of this one? What's the length? There's a mathematical term. There's a mathematical term starting with an n and ends with m. What's that? This means the length of the vector. Length of vector. Huh?
No.
Only two voices.
No.
No. Okay? This means the length of the vector. This means this. And how much is this for this vector? Huh? What's the formula? What's the formula for this? Which page on the textbook? Which page? Which page?
No.
Page 16? Thank you.
Wow, our model is so brilliant. Smart. This was smart.
Sorry. Where?
Our model give you wrong information. Stupid guy.
Page number 16, Mr. Review. No.
I'm sorry. It's close. Page 20. Page 20. Page 20. And for online students, this means how to calculate this length. This means square root. This part is square, and this part is square. Okay? If we say this is a, so it's a squared plus b squared. This is for 2 dimension. For 2 dimension, only 2.
A squared.
For exam purpose, that's enough. If could be 3 dimension, is a 3D, 3 dimension. Then there will, for 3 dimension, then that will be a squared plus b squared plus c squared.
C squared. Right.
Okay? Now, plug in this vector. Plug in this vector is a 3 squared plus 4 squared. I don't want to spend the time for this. The result is a square root 25.
25.
And the result is a 5. So the norm, the length, this is a 5. Okay, the length is a 5. The norm will be in the final exam.
No.
Of course, will be in the final exam.
This problem logic.
If I change the number, you should be able to do it.
Of course.
Right?
I'm there.
当然呢，对吧？
I'm an expert.
You should know the vector has a direction and has the length. Has a direction and the length.
So are there any specific questions for practice or examination for us?
You just this will be posted on YouTube, and you guys can watch it again. Okay? I will send the link. The link. So if I change the number, if I say this is a 3-2, it will not be a beautiful number, but you should be able to calculate the norm. Okay?
Because logic normal.
It's 20.
How's the recording?
Yeah, regular logic. It's still regular.
Okay, okay. Thank you. Okay.
Online student. Online student with you.
Yes, only six or seven students, not many. So, I give you a vector. You should be able to draw it. And today's new attitude is on this is the same thing. 3, 4. If I want you to draw the vector on this grid, this grid, there's no origin. Here, you have the origin. You have the origin. But like I said before, vector does not have origin. This is a 3, 4. If I draw here, if I starting from here, this vector and this vector are exactly same. This vector and this vector are exactly same. This is also 3, 4. This is also 3, 4. For example, I'm 70 kg. Okay, my weight is 70 kg.
Wow, perfect.
So this 70 kg, okay, I'm on the 5th floor. If I'm on the 2nd floor, this is a 70 kg. This one and this one are exactly same. It does not matter I'm on the 5th floor or on the 2nd floor. The 70 kg vertically downward and how long? The direction, the two directions are same. The lengths are same. So the two weight are the same. Doesn't matter. Say, oh, now you are on the second floor. So this one and this one are different. No, no, no. They are the same.
But if you go to the Mars,
So the origin, these are the same. All right. And let me draw it here. Draw. I'm not starting from here. Not starting from here. I'm starting from here. If this length and this length are same, I'm trying to draw it, then the three are exactly same. They are exactly same. Alright? It's like if I write 5 here, this is a 5. If I write 5 here, this is also 5. Okay?
yeah.
Doesn't matter I'm right on the right corner or on the down corner. 5 is a 5. Okay? Then this one doesn't matter starting from here, starting from here, starting from here. This is the same vector. It's the same vector.
No.
Okay, to draw this vector on this grid, you can start from any point. You can start from any point. Let's say start from here. How to draw 3, 4? How to draw this vector? Positive 3 is going right side. Okay, let me make it this. So 3. So it's a 1, 2, 3. Okay. Then 4. 4 is going down.
No, no. Upside.
It's not going down because it's a positive. So 1, 2, 3, 4. Okay. Ends over there. Ends over here. So this vector and this vector. So 3, 4. This is this vector.
Cool.
If you are starting from other point, if you are starting from here, that's okay. So 1, 2, 3. 1, 2, 3, 4. I'm sure I have to add 1. So 1, 2, 3. 1, 2, 3, 4. Okay. So this vector and this vector, or these, they are exactly same. They are exactly same. Okay. And many textbooks doesn't emphasize this. They are drawing this, give students the wrong illusion that the vector is always starting from the origin.
Origin. Yes.
And make students think this one and this one are different. These one are the three are 3 different vectors. The 3 are different vectors. That is wrong. That is wrong. Vector only has two things, the direction and the length. Okay, the direction and the length. For example, in a river flowing, okay, and let's say for some reason 2 kilometers per minute. Let's say this is the river flowing, okay, flowing east. Here is flow. Here is also. Here is also. Here is also. Here is also. Here is. All these vectors are same. All these vectors are same. You cannot say, oh, this is a downstream. This is upstream. Doesn't matter. If they are the same speed, then they are the same. If the weather forecasting says we have the wind, how to say the wind? Let's say there's a direction. Say today the wind is this direction. How to say northeast?
Northeast or northwest?
Or southwest.
North, south, east, west.
Today our wind is this much, 3 kilometers per whatever, per second. Let's say. In Kunming, okay. Now they found in Shanghai or in Beijing is also this. Is also this 3 kilometers per second. In Beijing and in Kunming. So is Beijing's wind is the same, is exactly same as Kunming's. Doesn't matter it is blowing in Beijing or is blowing in Kunming. They have the same length, 3. They have the same length. They have the same directions.
Yes.
So the two are same. Beijing's wind, we cannot say Beijing's wind is different from Kunming's wind. All right? So if I give you this, you should be able to draw it. You can pick any spot. You can pick any spot to start. If you say, I don't like the spot in Kunming, I want it starting from Beijing, you can do it. You can do it. This in Beijing, this in Kunming, they are the same. Just like this number 5. Somebody in US write it 5. This 5 in US. Are they different from the 5 I'm writing here in Kunming?
Not at all. No,
Right.
not at all.
Right. That 5 in US is the same as this 5. Alright. Now the summation and the plus and
Are you foresee?
so we review the norms. We reviewed the drawing, how to draw a vector. How to draw a vector. Draw a vector. Now we review how to add two vectors. How to minus two vectors. For this vector, 3, 4, we said the vector is just an advanced number. It's just advanced number. And if this is 1, 2, if I want to add it, there are two ways to do it. There are two ways to do it. One way, you just add it. Okay? Which page? Which page? Which page?
Addition of vector also.
Addition of vector. Huh? It's not in the book. This thing is too simple to mention. Is that too simple to mention?
Also, is this book written by you?
No.
No. It is just developed by, written by you. You are the author of this book.
Anyway, everybody knows. That thing everybody knows. 3 plus 1, okay? 4. And 4 plus 2, 6. This is the first way, okay? First way, you just plus. Alright? This is a two-dimension vector. This is a two-dimension vector, okay? And the result is a two-dimension vector. There's no such thing. There's no such thing. 3-dimension plus the 2-dimension plus the 3-dimension. This vector plus this vector. This is not right. Invalid. This is invalid. Okay? 2-dimension with 2-dimension. 3-dimension with a 3-dimension. This is the first way. Algebra. This is algebra. Algebra. And second way, okay, if it's minus, what's the result? Huh? Yes, 2, 2. It's a 2, 2. 3 minus 1 is a 2. 4 minus 2 is a 2. This is as simple as elementary school stuff. Yeah. Now the geometry way. Geometry way is what I'm worried. Is what geometry doing. Let's do plus. Let's do plus first. Let's do plus first. This one plus this one. We know is 4/6. To do the geometry. To do the geometry. Remember how to add two vectors. How to add two vectors. No cell phone, okay?
Avil, monitor, no cell phone.
Avil, no cell phone.
How to add two vectors. And how to add two vectors. I'm browsing your notebooks. Browsing your notebooks. Let me drink my tea. Browsing your notebook. How to do it? How to do it? How to do it? You guys are on recording, okay?
Please stop.
Stop
recording.
No, that's okay. Geometry.
Geometric way of addition of vectors.
Addition of two vectors. Like this is one first vector A, okay? From here to here, we moved from here to here, all right? This is a vector B, and this moved from here to here. So first step is from here to here. Then second step from here to here. The final result is from here over here. If the first vector is this, and the second vector is that. Let's say this is A, okay? This is a B, okay? This is A and this is B. And A plus B is what? A plus B is what? You move the B to over here. You move the B over here. Like I said, this one and this one are exactly same. You shifted. The direction is the same. The length is the same. So you shifted this over here. And the final result, A plus B, is from here to here. This is A plus B. This is A plus B. Vector, because it has the geometry property. It has a geometry property. It's not just a number. It's not just a number without a direction. So to understand the geometry is important. You said, oh, this is much simple. But this is not enough. The advantage is the direction. The direction. So we need familiar ourselves with the geometry stuff. And this can bring us a lot of goodies, give us a lot of advantages to prove the geometry questions. Like in high school, the geometry question can be proved by using vectors. I'm not going to review that part here today. And you can browse your notebook. We used this property, did some geometry proving. Okay, back to the specific question. How to solve this plus this over here? How to solve it? This is A, okay, it's over here. I use it. The B, 1, 2. Let's draw it. Let's say starting from here. Where is the B? 1, 2. Okay? So it's here. So now the question is this plus this. What's the result? This plus this. What's the result? You cannot say, oh, it's 4, 6. I want you to do it over here.
A plus B.
I want you to do it from here.
A plus B.
So it's A plus B, like this. A plus B, okay? This is an A, and this is a B. We need to shift this B. The end is, this B needs to be sitting over here, okay? This needs to be sitting over here. So, I'm out of the oops. Didn't draw well. Okay. So this B, since it can start any place, now I want to force the B starting from here. Okay.
Yes.
So 1, 2. 1, 2. Okay? So this B is here, is a 1, 2. So A plus B. So it's A plus B, okay. And the final result is from here to the end of here. It's a little bit overlapping, so.
Okay, is this the resultant vector?
The red one is the result vector. The red one is the result vector. It's this one plus this one.
Cool.
And you tell me what's the number for the red vector. You tell me what's the number for red vector.
A plus B.
Count it. Starting from here, okay? So it's 1, 2, 3, 4. Okay? So it's
4.
4. Okay, 1, 2, 3, 4. Okay? Now count. 1, 2, 3, 4, 5, 6, 6. Okay? So this one and this one are the same. Of course, yeah, they have to be the same. Okay?
Also, but the heads are touching to the 7th line. If we count.
Oh. So 1, 2, 3, 4, 5, 6. No, stops here. It stops here. This part is very important. I assuming it's on the board. It's on the board, and I assuming your notes has it. Head to tail rule, page 6. Page 6. Page 6. Head to tail. Head to tail.
Yeah, but
Head to tail rule. Okay. Okay, stop.